I am Dr. K.R. Jaikumar, Professor and Head, Department of Mathematics, KS Institute of Technology, Bangalore. In this semester, you are going to learn about Engineering Mathematics 4, which subject code is 15MAT41. As you all know, already first, second and third semester you have learnt. This subject consists of 5 modules. First one, numerical methods. Second one, numerical methods and special functions. Third one, complex variables and transformations. Fourth module, probability distribution and joint probability distribution. Finally, the last fifth module, sampling theory and stochastic process. Which are all the books you have to refer? B.S. Grewal, Higher Engineering Mathematics by Khanna Publications, 43rd edition, published in the year 2015. Also one more book by B.V. Ramana, which is also Higher Engineering Mathematics, published by Tata McGraw-Hill Company in 2010. So in this semester, the 5 modules we are going to taught you by 5 eminent professors from different parts of Karnataka of Visvesvaraya Technological University. I hope you have seen him. First module, numerical methods by Dr. A.H. Srinivasa from MIT, Mysore. Second module, numerical methods and special functions by Dr. Benchalli from Basveshwara Engineering College, Bagalkot. Third module, complex variables and transformations by Dr. Shanmuka, PESC, Mandya. Fourth module, probability distribution and joint probability distribution, of course myself, Dr. K.R. Jaikumar from KSIT, Bangalore. Finally, the fifth module, sampling theory and stochastic process by Dr. K. Basavarajappa, PIET, Davangere. In the lower classes, you have studied about the probability. I am starting with the fourth module, probability distribution and joint distribution. In the lower classes, you have studied about the probability, but our syllabus here, it starts with a random variable. First, let us recapture the general ideas of the probability. Before going to the proper definition, let us see an example so that we can understand the definition of probability very clearly. What is an example? If we toss a coin, very simple example, if we toss a coin, there are 2 possibilities, either we may get head or tail. So that is written here S, which is called sampling space, So probability of getting head, out of those 2, H or T, our possibility is only going to be H, so only one. Total elements in that S is 2, H and T. So total elements are 2. You are having a possibility of getting only the head. So probability of getting head is equal to 1 divided by 2. Probability of getting head is equal to 1 by 2. That is, it is our favorable, this is total. Same way, probability of getting tail, again our favorable is 1, total it is 2. Same way, why can't we go for little bit? So, the second example, little bit not complicated, having more number of values. If we throw a die, then there is a possibility that we may get either 1, 2, 3, 4, 5 or 6. That is the possibility. Then probability of getting 1. There are totally 6 elements here. Out of 6 elements, only one element has 1. Total elements are 6. As we have seen in the previous example, probability of getting 1 is equal to 1 divided by 6. Same way you can calculate probability of getting 2, which is also 1 by 6, probability of getting 3, which is also 1 by 6, until 4, 5 or 6. The probability of getting 6 is 1 by 6. Suppose the question is probability of getting an odd number. Out of 1 to 6, we can see 1, 3, 5. The 3 numbers are odd numbers. Therefore, for us the possibility is 3 divided by total is 6. Therefore, 3 by 6 simplified 1 by 2. Same way, probability of getting an even number. There are 3 even numbers, 2, 4 and 6. Again the possibility of getting outcomes is 3, total is 6, 3 by 6. So, what this example says us? The process what we are doing, either we toss a coin or we throw a die, the process what we are doing, it is called random experiment. Why it is random experiment? The outcomes are either this or that. It is not fixed. So, it is a random experiment, and the total outcomes what we are writing is called the sample space. Event is a subset of sample space. So, random experiment, the attitude or the work what we are doing. Sample space is the total number of outcomes what we are writing. Event is the subset of sample space. We have written the probability of getting head is 1 by 2. The probability of getting 1 in throwing a die is 1 by 6. I already told that 1 is favorable, denominator is total. So, how we define the probability? The total number of favorable outcomes. The total number of favorable outcomes divided by the total number of outcomes. In other words, the total number of outcomes, all outcomes you write it in the denominator, numerator it is only favorable outcomes, which says the definition of probability. Now your syllabus, the 4th module, starts with random variable. In random variable also I should use probability. That is why I have given you what is the definition of probability. Now again an example to say what is meant by random variable. Previously we have seen a coin is tossed. Now let us toss 2 coins. What are all the possibilities? 2 coins are tossed. In both the coins I may have head, one head, another tail. So in this tail, another head, both may be tail. So we get sample space S is equal to HH, HT, TH and TT. What is my random variable I am going to define here based on the number of heads. In the first element you can see there are 2 heads. In these 2 elements there is only one head. Here there is no head at all. So in the total sample space either 0 heads or 1 or 2. 0 heads it appears only once, in this it is 0 heads, TT. Then 1 head in these 2 elements. So there are 2 elements with 1 head and there is one more element 1 with 2 heads. We have given already the definition of probability. What is the probability of getting 2 heads? In only one element I have, the total elements are 4, so 1 divided by 4. the probability of getting only one head, there are 2 elements, so 2 favorable, divide by total is 4. The probability of getting 0 heads, again there is only one element, 1 by 4. See this table, heads, 0 heads, 1 head or 2 heads. So number of occurrence, so 0 heads in only one element, 1 head in 2 elements, 2 heads in 1 element, total outcomes 4, whatever you are written here 4, the total it will come here. The probabilities 1 by 4, 2 by 4 and 1 by 4. One more point you observe, I have not written there but you should observe. What is the total value of that probability? 1 by 4 plus 2 by 4 plus 1 by 4. Numerator will become 4, 4 by 4 cancels, total it gives you 1. Remember that, I will give you definition in the next slide, there you can find. So the total probability is going to be 1. Why can't we say little bit complicated example? Instead of tossing 2 coins, let us toss 3 coins. Total number of outcomes, there are 8. 1, 2, 3, 4, 5, 6, 7, 8. Quickly I will tell you. There are 3 heads, 2 heads, 1 head, there is no head at all. So 0, 1, 2, 3. These all are the occurrence, number of occurrences it appear. How many elements it has? You can see 0 heads in only 1, 3 heads in only 1, 2 heads in 3, like that, and probabilities also. See the table, heads 0, 1, 0, 1, 2, 3. 0 heads only T, 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 triple T 1, triple H 1, 1 head in 3 elements, 2 heads in 3 elements. So total outcomes 8. Probabilities 1 by 8, 3 by 8, again 3 by 8, 1 by 8. Here also you observe what is the total of this, 1 by 8, 3 by 8, 3 by 8, 1 by 8. To numerator 3 plus 3, 6 plus 1, 7, 8, 8 by 8. So the total probability is 1. So what is a random variable? You are assigning some value to the variable. Say this, random variable. A variable whose value is determined by the outcome of an random experiment is called a random variable. A random variable is also known as a stochastic variable. Remember this word, stochastic variable. In the 5th module you will get in the Markov chains. So random experiment, whatever the work we are doing, it is called random experiment. If you are assigning a value to the outcomes of that random experiment is called random variable. There are 2 kinds of random variables. One, discrete random variable, and another one, continuous random variable. Discrete random variable and continuous random variable. What is discrete random variable? If the random variable takes on the integer values such as 0, 1, 2, 3, then it is called discrete random variable. Whatever the examples I have shown you, either tossing of 2 coins or tossing of 3 coins, which belong to discrete random variable. You have seen the occurrence 0, 1, 2, 3, etc. What is the number we have assigned? What is the probability? So that is called discrete random variable. Why always coin? Why always die? Any other example is there? See that the number of telephone calls received by a person. So how he is receiving phone calls in the for him? That is also discrete random variable, because without mobile no one is there. VTU announces mobile is banned, but we can see all the students having the mobiles. So that is a good example, the number of telephone calls received by a person. What is a continuous random variable? If the random variable takes on all values in a certain interval, then it is called continuous random variable. Example, heights of the students in a class. Rather than that, one more good example which you like I can give you is the marks obtained by the students in a particular subject, because 30 to 40 marks, how many students, there will be so many number of students those who got 30 to 40 marks, 40 to 50 marks, like that we can define 30 to 40, 40 to 50. So in the interval we are defining the numbers, which is called continuous random variable. I already told you while showing the tables, please note certain things. The total probability is 1, and also we have noted the probabilities are more than 0. This is very important one. Probability distribution function. If x is a discrete random variable which takes the values x1, x2, x3 with the probabilities p1, p2, p3, then pi is called the probability function which satisfies the following conditions. What is the first one? Your probability should be more than or equal to 0. Total probability should be equal to 1. Here I should mention one thing. In the answer scripts, while writing the students, because in a class 1000 times we say probability lies between 0 and 1, 0 and 1, because 0 is no probability, 1 is perfect probability, those two we cannot see, very rare. So the probability lies between 0 and 1. 1000 times while completing this module we are told. Even in the papers answer script what we are seeing, the answers will be in hundreds, thousands. So at that time immediately you should get in your mind something you have gone wrong while answering the question. So you should see that your answer must be between 0 and 1. It cannot exceed 1, you cannot have negative also. That is what this probability distribution function says. It is a definition. Your each probability is greater than or equal to 0. If I make the sum, the total probability will be equal to 1. Keep in this mind, almost 90% of the problems we work only based on this definition. For a discrete random variable, there are 3 results which also we have to use it in while doing the problems. Mean or average, it is denoted by mu and it is given as expected value E of x, we can say, which is summation x into p of x. Then variance, it is called sigma square, summation of x square p of x minus mu square. That x square p of x is also called as E of x square, expected value of x square. Standard variation or standard deviation, which is nothing but root of variance, usually called standard deviation. So it is root of variance, nothing but sigma. The above value variance whatever you are getting, take a square root, you will get the standard deviation. Now again, once again I am showing the example, same example, considering tossing 3 coins we get S is equal to our heads are 0, 1, 2, 3, number of occurrence, how many times it appears, 0 heads in only 1, 1 head in 3, 2 heads in 3, again 3 heads also in 1, the probabilities 1 by 8, 3 by 8, 3 by 8, 1 by 8. Why I am showing, you can verify the definition what I have given. Each probability here it is strictly greater than 0. We say greater than or equal to 0, but strictly it is greater than 0 here. And if I make the total probability, it is equal to 1. So that is how the probability distribution function is defined. Now I am taking few examples or the problems in the university examination, how they ask. On the same way we are seeing 3 examples, I will do it, you can check. First one, the probability density function of variate x, variable can also called as variate. So variate x is they have given x values 0 to 6. P of x as defined in terms of k, k, 2k, 5k, etc. What are all the questions? Find k. Probability of x greater than or equal to 5. Probability of 3 less than x less than or equal to 6. What is the mean value? What is the variance value? They are asking. How to calculate it? How to calculate it? What is the definition we said? Summation of probability of x, total probability of x is equal to 1. So, in the example I can see k plus 2k plus 5k plus 7k, 9k plus 11k plus 13k, totally is equal to 1. They have given it is a probability density function. So, I can assume the total probability is equal to 1 by the definition of probability distribution function. So, k, 2k, 5k, 7k, 9, 11 and 13. What is the total counted? 2, 3, 8, 15, 24 like that. So, you will get 49k. So, my k value is nothing but 1 by 49. That is the first result I have given. So, k value is 1 by 49. What is the second question? This is the first question they have asked. What is the second question? Find the probability of x greater than or equal to 5. I would like to suggest one here. First you write in terms of k only, addition will be easier. You can do the addition, finally you can substitute what is the value of k. What they are asking? Greater than or equal to 5. That means there are two elements, one is 11, another is 13. So, 11k plus 13k, that means 24k. We know what is the value of k, just now we have calculated here, k is equal to 1 by 49. So, this is equal to 24 divided by 49. Be careful while asking these probabilities. If it is strictly greater than, you have to take only 6. They have given greater than or equal to, so you should take 5 also. What is the second question? Sorry, third question. See that? Probability of 3 less than x less than or equal to 6. Here very strict idea. X should be more than 3, you should not include 3, but here you should include 6. So, I should take 4, 5 and 6. What is the fourth one? It is 9k plus 11k plus 13k. What is the total? It comes to be 24 plus 9, 33. So, what is my answer? 33 by 49. Observe the questions very clearly. In the second question, they said greater than or equal to 5. Therefore, both the values 5 and 6 should be taken. Here 3 less than x, strictly less. That means x is greater than 3. X is greater than 3. So, 4, 5 and 6. What are all the other two? We have given the formulas. One they are asking mean value, another they are asking the variance. What is mean is equal to, formula already given, mu, which is nothing but E of x, which is nothing but summation of x into P of x. That means x values are available in the table, P of x values are available in the table, multiply 1 by 1, 0 into k, 0, plus 1 into 2k, 2k, plus 2 into 5k, 10k, like that if you write, last one 13 into 6, that if you write you will get the total as 202k, 202k, which is nothing but 202 divided by 49, k value is 49. People have a doubt, sir, you only so told the probability lies between 0 and 1, you see the mean value 202 by 49, it exceeds. Please note that we said the value of k, the probabilities will be between 0 and 1, not mean or variance. Mean or variance can exceed 1. Only the probabilities will be between 0 and 1. What is the second? One more question they have, variance. So it is sigma square, that is E of x square minus mu square, that is summation of x square into p of x minus mu, just now we have calculated 202 by 49 its square. What is the meaning of this? Square x multiplied with p of x. First one is 0, 0 square is 0 into k, so 0 only. 1 square is 1, so into 2k, so it is 2k. But when it go to the second one, it is 2, 2 square 4, 4 into 5, 20. Correct? Like that you write until the last one, you will get the simplified answer as 6824 divided by 49 square is nothing but 2401. Altogether simplifying of this, here you will have the last value minus this 202 by 49 whole square, the total answer it is going to be 6824 divided by 2401. So how to find the value of k, how you will get the probabilities. In this example you have only k, so you are very easily finding the value of k, probabilities, mean and variance. Let me give you one more example. Second one, see the problem. It has, observe the last 3, 5, 6, 7. It has k square, 2k square, 7k square plus k. So it will become a quadratic equation in k. You will get 2 values of k, out of which has to be chosen, that is also a question. You will get one negative value or more than one, only one value will be suitable, only that value I should take. Now the example again, the probability density function of a variate x is given by like that. Find k, x less than 6, greater than or equal to 6, 3 less than x less than or equal to 6. First let us start k value. What are all there? K, 2k, 2k, 3k, then k square, 2k square, 7k square plus k. So it is also given summation of p of x is equal to 1, then 0, k, 2k plus, again they have given 2k plus 3k, then k square, 2k square plus 7k square plus k is equal to 1, is equal to 1. So you can find how many k squares are there? 7, 9, 10, 10k square. What about k? 2 plus 2, 4, 5, 8, 9 plus 9k is equal to 1. 10k square plus 2, 3, 4, 5 plus 3, 8 and lastly one value 9. That is what I said, you get a quadratic expression in k, 10k square plus 9k minus 1. Find the roots of this equation. In the lower classes you have learned, also in second semester differential calculus, to find the complementary function you are finding the roots and writing the complementary function. So you are familiar with how to find the roots. Calculate it. It is minus 10, 9. So 10, 1 minus, that is multiplication of these two should give this, addition of these two should give 9. So 10k square plus 10k minus k minus 1 is equal to 0. From these two and these two, from these two 10k is common, I will get k plus 1. Here minus 1 is common, I will get k plus 1. Group together k plus 1 into 10k minus 1 equal to 0. So k plus 1 is equal to 0 or 10k minus 1 is equal to 0. Therefore k is equal to minus 1 or k is equal to 1 by 10, in other words 0.1. We got two values of k. Which has to be chosen? Very clear. I should use k is equal to 1 by 10 because minus 1, two categories, negative values are not available. 1 is also, I said, it is very rare case. So this we cannot take. K is equal to 1 by 10. Afterwards, probability x less than 6. Again, one more idea I am introducing. See, if there are too many quantities to calculate, if there are too many quantities, then in probability we have one concept, what is called P of A plus P of A dash is equal to 1. So any one will be 1 minus I can use. P of A plus P of A dash is equal to 1. 1 minus we can use. What is the first question they have asked? Probability of x less than 6. This is the question they have asked. See the table, x less than 6, how many quantities I should take? 0, 1, 2, 3, 4 and 5, x less than strictly. Therefore 1 to 5 I should add. Instead of that, if I take 1 minus probability of x greater than or equal to 6, based on this rule, based on the first rule, P of A plus P of A dash is equal to 1, based on that rule, I want x less than 6, I know the total probability is 1, it cannot be less than 1, or so total probability is 1, I can write 1 minus, here you while writing it should be very careful. Sometimes here it will be equal to, then here it is only strictly greater than. Here it is strictly less than, that is why I have used greater than or equal to. What is the advantage here? Now I can sum only two quantities, 6 and 7. What is 6? 2k square. What is 7? 2k square plus k. Only two quantities, easy for calculation. You substitute the k value as 0.1, simplify it, you will get 81 by 100 or 0.81. If you do that way also, it is lengthy calculation, if you do that way also, your answer is not going to be changed. See, in the examination time restriction is there. In the house if you sit and calculate, there is no time restriction. You can try both for a problem and you can clearly verify yourself that, oh, whatever the method I am using, the answer will not change, it is correct. For this alone, what should I write? 0, 1, 2, 3, 4, 5. All these values you add it up. All these values you add it up for 0, 0 only, k, 2k, again 2k, then plus 3k, correct? For 5 it is k square. You you apply all the k values, these values you should take. So add all these two, again you will get the answer as 0.81 only, there will not be any change. So whatever the method, but using the calculation purpose, this is easier, this is easier than this. In the distributions also we use this kind of techniques. I must need this. So when it is given x less than 6, I can use 1 minus x greater than or equal to 6. What is the next question? Of course, which is same, x greater than or equal to 6, x greater than or equal to 6, you know very well, you write x is equal to 6 plus p of x is equal to 7, both the values you add, you will get 0.91 or 91 by 100. Now p of, this is also again previous problem also we have seen this example, here also p of 3 less than x less than or equal to 6. I will write clearly for your idea. Do not include 3, I need 4, 5 and 6. In this, that 1 minus probability idea, it will not work, between the values you should take. So strictly greater than 3, that is why I started with 4, then 5, then 6. For x is equal to 4, I have 3k, for x is equal to 5, I have k square, for x is equal to 6, 2k square. Apply the k value, make the calculations, you will get 0.33 or 33 by 100. Because k value is 1 by 10, it is obvious. K value is 1 by 10. If I use in this, k square will become 1 by 100. So 33 by 100 or 0.33. So in this concept, that 1 minus, it will not work. You have to choose clearly greater than, less than or equal to, like that you should take. Whereas if the calculations are more, in that cases we can reduce the number of calculations so that we can get the results easily. You can use calculators, but use the calculators properly, correct, do not make any mistakes, because there only. And in mathematics papers we do not allow, I can say, writing like 10 power minus 3, 10 power minus 2, do not write like that, write the clear complete decimal 0.001004, like that you should write 10 power minus 3 minus 2, like that do not write, because in a calculator you will get. There is an option in the calculator also, you can press one letter ENG or some thing, you will get the total decimal, write the decimals. You can make a note of this problem and you can work same way. It gives the probability density function of variate x is, it is given x. Well, please note that why I am showing the different examples. In the first example, all x values are 0 to positive values, probability is only in terms of k, you can calculate it, k greater than, less than, mean, variance, it is a good example which gives all the values. Second one, what is the change you have seen? You are seeing k square. When it comes to k square, you will get two roots, properly assume the root, the value of k which is less than 1, not more than 1 or negative value, because k is in the probability, you cannot have negative value, be careful. Now in the third example, x can be negative, minus 2, minus 1, 0, 1, 2, 3, the values are given, correct, but since the total value it is going to be 1, if you use this, what happens, minus 2.1, minus 1 into k, 0 into 2.2, 1 into 2k, 2 into 0.3, 3 into k, like that if you multiply and add, the total will be equal to 1. If you find k, it gives you 0.1. They have asked find mean, variance, standard deviation, mean 0.8, variance it is coming 2.16, whose root is 1.47. So root of variance is standard deviation. You can try that problem. 3 problems I have shown you with the different categories, one with k, another with k square. Capital X can be negative, but the probabilities and k value cannot be negative. In the university examination, such type of questions are oftenly coming. Even the second question, it is repeated for more number of times. So you can see such type of problems. Now in the second problem we have worked. For the next topics, I will start with distributions. Still continuous random variable is there. See, in the syllabus what happens, first discrete random variable, then they have given continuous. For discrete random variable we have 2 distributions, one is binomial distribution, another is Poisson distribution. So we will do that first. Then we go for continuous random variable, there we get another 2 distributions, exponential and normal distributions. So in all the problems, 99% of the problems will consist of these 3 questions only. Important points to be remembered. What they ask, there will be 3 questions. One is called exactly, then at least, then at most. Examples I have given. Exactly 3 means what I should do, I should put P of x is equal to 3, there ends the matter. Put P of x is equal to 3, you substitute in the distribution, you will get the solution. Second, at least, same 3 only I have used. At least 3 means minimum you can have 3, maximum until the number n. This is how where I already used one problem, x less than 6, greater than or equal to 6, like that. Here minimum you should have 3, then what are all the other values until n, n is the variable, maximum values, until n you can have. So at least 3 means P of x greater than or equal to 3. Here our common sense should work. Suppose my n value is 10, I cannot take from 3 onwards, 3, 5, 6, 7, 8, 9, 10, I should do too many calculations. Instead of that, if I use 1 minus, there you can see greater than or equal to 3, that is why strictly I put less than 3, easy. 1 minus x less than 3 means I should do only 3 calculations, x is 0, x is 1, x is 2. These 3 calculations if I do, I subtract with 1, I will get the answer. Then what is the other point they will ask? At most. At most 3. So maximum you can have 3 in that set. That means it starts from 0, 0, 1, 2, 3. So there will not be any confusions in exactly and at most. When it comes to at least, be careful, minimum 3, from 3 to n I should go. So too many calculations I cannot do it. I can do 1 minus P of x less than 3, so that it gives only 3 calculations, 0, 1 and 2. In the entire probability distribution chapter, under the 4 distributions, binomial, Poisson, exponential and normal, these wordings are most important. How to calculate this, be careful, because what happens in other modules, the questions cannot be twisted. If I use Taylor series, if I use Euler's modified, I should ask solve the equation by using Euler's modified, using Taylor series. But if one who knows the English very well, if the question paper setter, then in the probability he can play. Therefore be careful with the wordings what they give. This is important points to be remembered. Now discrete probability distributions. There are 2 discrete probability distributions. One is called binomial distribution, another is called Poisson's distribution. Don't get confusions. we have defined random variable. There are two types of random variables, discrete, continuous. We have seen some problems on discrete. Definition is given, still I have to do problems on continuous. I am going to the continuous part, that means discrete probability distributions. I have done discrete random variable, discrete distributions. So binomial distribution and Poisson's distribution. What is binomial distribution? Here also the probability distribution function is P of x is equal to NCR P of x Q of n minus x. NCR P of x Q of n minus x with the condition that P plus Q is equal to 1. P plus Q is equal to 1. What is the meaning of that? Binomial distribution, you know binomial series. Binomial series. For example, 1 plus x power n. 1 plus x power n or 1 plus x minus n. 1 plus x power minus n. So, P of x is NCR P of x Q of n minus x. If I keep on changing the values of r, if r is equal to 0, r is equal to 1, r is equal to 2, like that. Even we can write NCX instead of NCR, that is the correct word, NCX. So if x changes from 0 to n, you can get the values clearly. So it gives the binomial series P plus Q power n, it gives a binomial series. I will explain you in the next class how that NCX, if I take NCX P of x Q of n minus x with P of y, P plus Q should be equal to 1 because it is essential. P plus Q power n, it is 1. In the derivations we have to use it. Most important university questions, binomial distribution, Poisson distribution, exponential distribution or normal distribution. Find the mean and variance of these distributions. These all are most important questions. For that, in this binomial distribution, I should have P plus Q power n is equal to 1. And we use these points extensively. What happens when it is exactly? What happens when it is at least? What happens to the probability when it is at most? We calculate this. So you should go through before the second class. What about the random variables? Then discrete random variables, how we have calculated the table problems, how we have calculated k and how we have worked the probabilities, how we can calculate mean, variance and standard deviation, because in these distributions also I am going to use the same formulas for mean, variance. We will derive mean and variance of the particular distribution, then we will do the problems which consist of those three words. Work, you can see many number of examples in the textbooks. Take not only the Grewal and Ramana, B.V. Ramana book, extensively books are available for probability and random process. You take those books. Sham series are also, books are also there. You will get more number of examples in that. So take that and work it out. Okay, good luck.